We wish all the Muslim students Ramadan Mubarak, and I hope that our deeds are accepted during this blessed month. So now continuing our learning on MATLAB. So this week we're going to cover working with matrices, so that's chapter 3. From last week lab work, I think there are 4 students who did not attempt to do the lab work. So there's no effect on the overall assessment marks, the coursework. If you did not do the lab work, only your attendance will be absent. And at the end of the semester, if you are on the border, meaning that your overall marks is nearby the border, like from B plus to A minus. So I will refer to the attendance, to the lab works, to see whether I can use that as extra credits. So that's all. Yeah, Mawadda, do you have any question? You are raising your hand. I don't think so. Okay, so let's move on to working with matrices. So from mathematics, there are 3 terms, 3 different terms. These are scalar, vector, and matrix. Okay, those are from mathematics. The interpretation, I think you know already what a scalar is. A scalar is just a number, it's a single value. A vector is an ordered list of numbers. It's one-dimensional. It's either a row vector or a column vector. A matrix is a rectangular array of numbers. It's multidimensional. So you have m by n matrix, right? So that's from math. But in MATLAB, all of this scalar, vector, and matrix, they are regarded as matrix. MATLAB matrix laboratory. So matrix. So a scalar is just a matrix with one row and one column. Well, in math also we can view a number like that, right? A number is a subset of a matrix. So in MATLAB, a matrix is just a thing with one row and one column. A vector is either a matrix with one row or a matrix with one column and many rows, or one row with many columns. And then a matrix is viewed as a common matrix with certain numbers of rows and columns. Okay, kind of the same. So all calculations in MATLAB are done with matrices. That's why we regard scalar and vector are as matrices. Matrices are defined inside a pair of square brackets, okay? Square braces. So if you want to define a matrix, you're going to have that pair of square braces. If you only have one number, as we have done before, you can just type the number. But if we type a square braces with a number, that will become a scalar too. And then, how do we separate the row? We separate the entries in a row. That would be using a comma or a space. How to separate the entries in a column? That will we will use semicolon or the enter key. Okay, so let's do that. So let's define a scalar. A scalar equals to, let's say, 3.1415. Okay, so that's a scalar, just a number. If you take a look at the word space, is just one number. You can also do scalar and enclose that number with for some reason, if you like to, then you will also get the same result. Okay, so that's a scalar, a vector, vector 1. Let's say we want to create a row vector. So the separator in between elements in a row is a comma. So 1, 5, 7. That's a row vector. We can also do one space. I prefer this one. Okay, 1, 5, 7. We save some space, right? If comma, then we have an extra two characters. So 1, 5, 7. Still the same thing. And then if we want to create the column vector, so that's vector 2. So separate 1, 5, 7 by semicolon. Okay. Enter. So that's a column vector, or you can use the enter. This 1, enter. Oh, I can't do that. 1, enter 5, enter 7, and then close the square brackets, and then enter. So you have that 1, 5, 7. Okay, so whichever that you like. Usually the second one, the one with enter, if they save this vector definition in an M file. So if they think that it's easier to separate the matrix like this, easier for them to see the form as a matrix. Okay, for example, let's go to our M file, edit. Okay, let's create one matrix. Okay, we can create a matrix. Oh, okay, let's do matrix first, and then we'll go ahead and do this. No? Okay, so matrix. If you want to do matrix, this is a combination of the row separator and column separator. So matrix, for example, we want to do a 1, 2, 4 by 3 matrix. Okay, so we start with 8, 12, 19, 7, 32, 12, 4, 23, 8, 1, 1. So we have the matrix. Okay, so if you take a look at this, it's one line, so it's difficult to see in an M file. Okay, so let's go to our M file, edit. So for example, we want to copy this and paste here. I'm gonna, as usual, clear CLC. Okay, so I'm hitting F5 to automatically run this coding, F5. And then I can save my coding. I'll save it in my desktop first. I don't have desktop now. Okay, this is chapter 3. So if you save an M file, you cannot use a space in between. Okay, for example, let's use a space. 3 with a space. Save. Then MATLAB says that you can't run this file because there is a space in between. So you can use the same rule as we have learned before, but to separate the words with underscore, or you just compact all the words together. See? And then change folder. Okay, so this is the matrix definition. So you can see the matrix in the output. In the input, it's quite difficult to see. So what we do is because this is like a notepad, so any empty space in between is ignored by MATLAB. So let's see if we hit enter like this, whether MATLAB will still run. Chapter 3. Oh, we can. So we have to like that. Okay. So F5. And then we want to separate the matrix not by semicolon, but now by enter. Enter. And then I'm going to replace the semicolon by the enter. So F5 this. So yep, it's running. Let's see whether I can adjust a bit. That will still work. Yeah, F5. Yeah, it's working. Okay. So for so you can do enter the enter separator. If let's say you're writing matrix in an M file, okay, so that you don't want to see it here because at last you want to put semicolon here, but you want to at least see that okay, my matrix is like this. Okay, you can adjust some more. Okay, make the alignment so that you can see better. Okay, so that's the use of having enter as the column separator. F5. Yeah, so it's not, so you have a semicolon here. You don't have any output, but you still have the matrix right here. Okay, what's that? So we have covered these examples. So how do we combine rows and columns? Different vectors and matrices can be combined together to define a new matrix, as long as the dimension matches. Okay, same as when we want to build matrix by hand, right? As long as the m and n totals are the same. So the output needs to be a valid rectangular matrix, meaning the number of columns, number of rows has to be suitable to each other. And the row and column separators function in the same way when we want to combine the rows and columns. Okay, so let's do the example. Let's say we create a row vector 1 equals to 1, 2, 3. So I don't want to see the output. Okay, so that's a row vector. We check here. So I'm going to clear first. Clear CLC. So I'm going to repeat the instruction. Row vector equals to 1, 2, 3. So every time you compile the coding, check that okay, in the workspace we have a variable named row vector. And then the second row vector, I'm going to name it as 3 to 1. Okay. Now we want to combine both row vectors. Okay. Depend on us how we want to combine them. Do we want to combine them? What's the term? On top of each other, like row vector, and below row vector is below row vector 1 is row vector 2. We can do that. So we have combined row vector. I'm just naming the variable. So we can create another matrix with the row vectors combined. Okay. So we want to have row vector 1. Enter or semicolon row vector 2. Okay, so they will be combined. But if we want to combine side by side, we just use space or comma, right? Enter, so it will be arrayed side by side. Okay, same thing with column vector. Okay, for example, we have column vector 1 equals to 1, 3. Then column vector 2 equals to 2, 8. So if we want to combine them side by side, we use the space, right? Combine column vector equals to column vector 1, column vector 2. Okay? And you can also do combine column vector by semicolon. So you have still one column vector. Okay. What about if we combine the column vector with the row vector? Okay, column vector 1 with row vector 1. Let's do that. Row vector 1 with column vector 1. See what happens. Okay, error because the dimension does not match. Okay, so this is nice actually. In my time when I learned MATLAB, we don't have this. So if there's any error, MATLAB will just say error here without any information. So this is nice. We have the error message. Dimensions of arrays being concatenated are not consistent. So yeah. Okay, moving on. Covered all the examples. Now we want to learn how to make our life easier in creating vectors, because this is good, right? We have only 3 elements in a vector. What about if we have 1,000 elements? Okay, we cannot type all the numbers. We have to have some built-in function to help us do that. So we're going to learn 2 built-in functions. Number 1 called colon operator, and the second is linspace. Okay, so they are both used to help us create a column or a row vector. Okay, so we start with the colon operator. Usually the type of data used will be vectors. The colon operator allows you to create an incremental or decremental vector of regularly spaced points. It's uniformly spaced by specifying the start, the increment or decrement, and the stop values. Okay? So if in the future, in your work, in your research, you kind of know, you know the start value, you know the end value, you know the increment or decrement, you can use colon operator to generate the row or column vector. Okay? So for example, if we want to create time from 0 to 23, and we want the increment to be 100. Okay, that's 1 hour. We can do that. 0 colon 100 colon 2300. Or you can reverse the order. We start with 2300 and we end with 0, with the increment being negative 100. So let's do that. Here, CLC. So for some reason you wanna create time. Time equals to 0, 100, 2300. Okay, so you have a row vector of 24 columns specifying the time in incremental hour. Okay, or you can do the other way around. 2300, the decrement is negative 100 until 0. We have that too. Okay, let's see what now. Let's see if you have 2300, but you forgot to put the negative, but with 0. One time 0. Okay, so yeah, interesting. This is difficult. See, this is an error, right? Oh, 2300. Let's see, kind. It's an empty vector. Okay. So please be careful with your coding, right? Right here, this is, you want to start with 2300. The increment is 100. The endpoint is 0. This is, of course, an error, right? But MATLAB still run the instruction without any error message. So imagine if you're writing a big M file and you write it's so difficult to identify this bug. Okay, for just one, if you just miss the negative sign. Okay, so again, whenever you're writing long coding, please check one by one. Write one line of code, enter, check, the answer is correct, okay, save that, and then add another line, add another one. This has been a big problem, especially for me and my friends when we do our master and PhD research. So we are greedy. We want to write as many lines as possible and run it, and then nothing happens, and then it's difficult, to go back and see where we did wrong. Okay, so we have to have 3, but colon operator also takes 2 inputs. Okay, so this it takes 3 inputs: the start, the end, and the increment or decrement. But colon operator also takes 2. So for example, you want to have 0 until 10. Okay, let's see what happens. Okay, so if there are only 2 inputs, MATLAB will, by default, assume the increment is 1. Okay, so when you specify 0 to 10, then yeah, MATLAB will just, the difference between consecutive numbers is just 1. Okay, so do 0, 100, so still the same. Okay, so the number of elements will be different, but the number of increment would be the same, that is 1. Okay, so let's go to namespace. Namespace cater the same need, but using a different method, different approach. So namespace generates linearly spaced vector. So the spacing is still uniform, similar like the colon operator, but the format is the start value, the end value, and the number of points. Okay, so suppose that we want to create the vector that we created before, time. So we start with 0 and with 2300. So there's no increment, decrement values, right? There's only number of points. So we want to create 24 points uniformly spaced between the start and the end points. Okay, so let's do that. Here's CLC. Time equals to namespace. Namespace stands for linear space. Namespace 0 to 2300. We want to create 24 elements. So we still have the same values. Okay. So if you wanted to create 2300, 0, 24. So the same thing backwards. Okay, so this is quite good because the probability of you not entering the sign, right, the positive, the negative with the colon, you have to be careful with the positive and negative in the increment value. But here you can just state your start point and end point and the number of points, provided that you know the number of points. Okay, so this is useful. For example, if you want to define, let's say you have an interval from 0 until 10. Okay, for example, I'm not not sure whether you have finite difference or not, 0 until 10. So whenever we want to do numerical analysis, we have to partition the interval according to the number of partition that we choose. Okay. For example, if you're doing research, you will start with a small number of partitions and you will increase number of partitions. So you want to start with 10 points in between 0 and 10. So you have your vector. Okay. 10 points. Okay. So see, this is 10 points, but you start with 1 until 10. Then you have the even the nice values 1, 2, 3, 4 until 10. But if you start with 0, the linear space will still force the vector to be 10 points with increment of 1.11111. Okay. And then, okay, let me see. So if you want to define, let's say, so 0, 10, let's say 11 points. Okay, so we have the nicely partition interval. And then after we have done all the process and everything, we say that, okay, the results are good and everything. I want to try to make the spacing smaller. So we can do 11. We don't have to think about this. If it's not important, then we can just say, okay, I want to try 21. Okay, so MATLAB will automatically divide the interval for you. Okay, so both functions and operator works the same, but with different styles. Oh, then we have one more. The linked space also takes 2 inputs instead of 3. So let's see what happened. So if you do linked space 0, 10. Let's see 1. Okay, so with linked space, whatever value, if you just have 2 inputs, the start linked space will treat that as the start point and the end point, and linked space will automatically create 100 points. Okay, this 100 points in between those 2 numbers. Okay, so that's the default setting. For the colon operator, the default increment is 0.1. For the linked space, the default number of point is 100. Okay, whatever value you put, linked space 1.3 to 3.6, so you still have 100 points of uniformly spaced points. Okay, so if you have any questions, please post in the chat. Okay, moving on. Listening space. So once a vector is created, you might need to extract only a subset of the data. Okay, that's normal. You want to just take a portion of that vector or that matrix. This is done through indexing using parentheses. So parentheses is used to call a part of the matrix. To define a matrix, you have to use square brackets. Okay. So in a row vector, the leftmost element has the index of 1. So in MATLAB, the counting starts from 1. Okay. So please be careful. In your mathematics problem, maybe the counting starts from 0, right? But in MATLAB, the first element is labeled as first 1. Okay, not 0. So in a column vector, the topmost element has the index of 1. Okay, so a row we start from left, 1, 2, 3, 4. Column vector we start from the top, 1, 2, 3, 4. So the format of calling the part of the vector is by calling the name of the vector and then the index of the vector. Okay, for example, in mathematics, if you start from x sub 0, right? So you want x0, x1, x2, x3, you want to call x4 in mathematics. So in MATLAB, you have to add 1, right? Vector parenthesis 5. Okay, you can either call one index or the range of indices. Okay, you can either do that. You can change the number in a vector by assigning to it. Okay, assigning, remember, assigning is equal, the equal sign. So let's do that. See? Let's create one vector using the colon operator. We start with 0 until 0.1 and 1. I have a typing mistake in my slide. I do 1.1. Let's try that. Let's see what happens if we start with 1.11. Okay, so naturally. Clear CLC. Vector 0, 0.11. So you have a vector. And now you want to call the third element. So the third element is 1, 2, 3, 0.2. Okay? So you type the name of the vector. And then you call using a parenthesis. Okay? So that the index is 3. You have 0.2. Okay? So that's how you call the element. But you can also assign. You change that, meaning that, okay, you have this already, but you see that, oh, this is not good. Maybe you have a data here. This is not good. So you check with your whatever, your vendor, your students, whatever, your vendor, and see that, okay, this is wrong. This is another value. So you just want to change this one. You can do that by calling the vector at position 3, and using the assignment. The assignment is equal sign, equals to, and put the revised value. Okay, let's say the value is 333. Enter. Okay, you see that the third element is changed from 0.2 to 333. Okay, you can also call a range of vectors. So let's say you want to call vector 3 until 7. Okay, vector 3. So now you can use the colon operator in indexing the elements. So here colon so this is different, right? We know that we're talking too much about it. Sorry. So we see 3, 7, like that. So we have 3, 4, 5, 6, 7. Okay. And now we want to do vector 3, 2, 7. We want to call that portion. So we'll have that portion from element 3, 4, 5, 6, 7. Okay. 333 until 0.6. So that's a portion of the vector. Sorry, I think I said that the default value when you have colon operator, when you have just two inputs, the default increment is 0.1. No, the default increment is 1. Okay. Okay, so you can also, when you can call the element, or in computer science they call this fetch. If you can fetch the elements, you can also change the element by assigning some values to it. Okay, so assign 777, 777. Okay, you see that the whole portion here is changed to 777 if you want to change to the same number. But if you want to change to a different number, you can use vectors here. Okay, the vector has to be of length 1, 2, 3, 4, 5. Okay, the vector has to be the same length of the extraction. Okay, so 5, I'm gonna just do the column vector 104 until 100 until 104. Okay, so that's a vector of elements. Okay, so we have changed the values to 100, 101, 102, 103 until 104. Okay, so the same thing can be done with a column vector. Okay, so I'm just gonna do one. For example, you have vector equals to do clear CLC. Vector equals to, this is column vector, 1, 2, 3, 4, 5. Let me do that. Let me try vector 1 until 10. So that's a column vector. You want to do vector equals to vector transverse. Okay, you can do that too. And then you can fetch, you want to fetch the fifth element of that vector. So the same thing, the same rule for row vector apply to the column vector. So that's indexing into vector and changing the values. Now we want to indexing into a matrix. Matrix has number of row and number of column. So we have to have two inputs, right? For vector, we can only have one because that's the number of elements. For matrix, we have to have two like this. Let's see what happens when we have one. Okay? So similarly, once a matrix is created, you might need to extract only a subset of the data. The format is matrix, and then you have a parenthesis. Row, the first input, column index is the second input. Row range is the first input, column range is the second input. The same with mathematics, right? We start the first input is the row. You can change the numbers in the matrix by assigning to it. The same thing apply here too. Only some notation. Okay, for example, you know how to create a matrix. So for making example now, I always use the random function to randomly create 8 by 5 matrix for me. Okay, so you can search for rand. I think we have covered this in our previous class. Random, they create one random number in between 0 and 1. If you want to create a number in between some numbers, like from -5 to 5, from 0 to 10, there's some smart line of coding that you can apply. So have a look at the rand documentation in the help section. Okay, they have that. You want to create random numbers outside 0 and 1. Okay, so we have an 8 by 5 matrix. Now let's fetch the third element. Okay, so this is the first, only one input. So we have 0.1270. This. So that means if we have one input, when we're fetching the values, MATLAB will automatically take the first column. Okay, we'll assume that we want to access the first column and the third element of the first column. Okay, but if we don't want that, we want the third row, but the second column, we have to give two inputs. Third row, second column. .1576. Okay, so this is the third row, second column. Okay, so you can do the same, meaning that you want to take a range. Matrix, the rows from 3 to 5, the column is column number 2. So you can do that. So you have that. That column vector. Or you want to take a range of the row from 3 to 5, but 2, the column from 2 to 4. Okay, you have submatrix. And if you want to assign the matrix, so you just call the values, the range of values. Let's say you wanna assign two new values here. So this is a 3 by 3 matrix, and maybe you assign 1, 2, 3, 4, 5, 6, 7, 8, 9. Another 3 by 3 matrix. Okay, you see that this part right here is changed to the one that we did before, right? This portion at the center. What about if you want to take the third column? The third column, okay? So matrix, you have third column, and row. Row is 1 until, how many rows do we have? 8 rows, 1 until 8, like that. Okay, so you have the third column. But there's an easy way to do that. If you want to take the whole thing, you can just do colon like that. Matrix, colon, comma, 3. So you'll have the same thing. Okay? Same with if you want to take the fourth row. Okay? So row number 4, and all the colon X here, colon with no input, acts as it will take the whole thing, the whole indices in that, meaning that in the fourth row. Okay? So we have all the values. Okay, next. Okay, we have covered this. I didn't put the colon part here. Let me write down. I'll update the notes. Just a second. Colon with matrix. Okay, next. Element by element operations. So we know how to define matrix now, matrix, vector, and scalar. How do we add them together, subtract them, multiply, perform the mathematical operations on them? An element of matrix is simply one of the numbers stored in matrix. A row vector of 10 elements, or a 10-element row vector, is a row vector that has 10 numbers stored in it. The 8th element of the vector v is the number stored at the 8th position of v. Element by element operations are performed on two matrices of the same size. Okay? So in MATLAB we have two terms. We have element by element operations, and we have just the operations. Okay? So we'll see the difference. That is, a particular operation is performed on the corresponding or the same position elements in the two vectors. So the matrix dimensions must agree. Okay, so this is element by element operations in MATLAB. So you have multiplication, division, addition, subtraction, power. So for multiplication, division, and power, you have the dot before the normal operation that we know, right? For example, multiplication, we have asterisk, the asterisk symbol. But for element by element, you have to add a period before the asterisk. Same here, the period and the slash, the period and the head. Okay, so that those are the element by element operation. For plus and minus, they don't have the period symbol because they're the same. Okay. Whether it's element by element or is a normal operations, they function the same way. So element by element multiplication, division, and power operators have period appended to the front of them. Addition and subtraction do not. Why? Because there are another operator, multiplication, division, and power, that are not element by element. Okay, so That's why MATLAB used the extra period to differentiate between these two operators. So you can use these operators with scalars and vectors only. For element by element operators, the number of dimensions must agree. Okay? So let's do that. There's CLC. Let's define a row vector 1, 2, 3. So that's a vector with 3 elements, and we have B equals to 4, 5, 6. And then C is a column vector 4, 5, 6. And then D is a column vector 1, 2, 3. Or we can do the transpose trick, right? C equals to B transpose, D equals to A transpose. Now, A is a row vector of length 3 with 3 elements, A and B. So we can do element by element operations between A and B because their dimension is the same. Okay, so we can do multiplication. A dot multiply B, that, right? A times B. So what is this? This is just element by element multiplication, meaning that 1 times 1, the first element of A times the first element of B. The 1 times 4 is 4. Second element of A times the second element of B. So 2 times 5, 10. The third element of A times the third element of B. 3 times 6, 18. Okay? Same thing with C times D, right? Because they are both column vectors of length 3. So the same thing. You do the operation element by element. So this is different with mathematics, right? If you have a matrix like C and D, C is 3 by 1, D is also 3 by 1. You cannot multiply two matrices together, right? But in MATLAB, you can do that by the element by element operations. Okay? If you want to do A, you want to increase the power of every element in A by every element in B, right? You have that. So the first element of A raised to the power to the first element of B. Okay, the second element of A raised to the second element of B power. Okay, like that. So the same with dot divide. So you can also do C dot power D. Let's try A. A is 3 elements dot power C. A is a row vector. C is a column vector. Okay? What is this, huh? What is A? A is 1, 2, 3. C is 4, 5, 6. So the first column is 1 to the power of 4, 1 to the power of 5, 1 to the power of 6. The second column is 2 to the power of 4, 2 to the power of 5, 2 to the power of 6. Yeah, interesting. I just noticed. I thought that it's gonna be an error. Yeah, so that's that. Well, what about if you have a vector a row vector 1, 2, 3. So you want to add every element in the vector with 2. So you can just do that. You add by a scalar, and automatically every element in the A will be added by 2. 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5. Okay? You don't have to do 1 plus 2, 2, 2, like that. Okay? We'll still have the same answer, but will take a lot of time to write that. What about if you want to bring 2 in front? So 2 to 2 minus a. So you can also do that. Just do a scalar like that, 2 minus a. So what MATLAB will do, if you have operation with a scalar, MATLAB will see, okay, A is a matrix or 1 by 3 matrix, so that this is a scalar. So MATLAB will change this into matrix of the same dimension, the other, with entries all the scalars, and then we'll perform the matrix operation, the element by element operation. So if you want to do A times 2, a bunch of examples in the slides, okay? Times 2, we'll do 2 over A, okay? You can do it right away. So for example, you have a data set, like some data set from some, you're measuring, like say, the temperature, and then we have 100 elements of vectors. And then suddenly you know that, okay, the temperature is inaccurate. The temperature is reading wrong temperature. So the 37 will be read as 35. So for all the data, you have to minus 2, right? So from MATLAB, you can just call the variable that's the variable storing the data and do a bulk subtraction, right? The data subtract 2. So then you will have the corrected version of the data. Okay, so some interesting result is if you do element by element operation, but with different dimension, like A and C, right? A is a row vector of 3 elements. C is a row vector of column vector of 3 elements. If you do element by element multiplication between them, so you would have like the first element, the first column is the first element of A times all elements in C. So that will be the first column, right? The first element of A is, what is A again? AC. So A is 1. So 1 times the whole thing. 1 times 4, 5, 6. So that will be stored here as the first column. 2 times 4, 5, 6. That will be stored as the second column and the third column. Moving on. So that's element by element operations. Then we have matrix operations. And these are the one that we learn in mathematics. Okay. So we have addition, subtraction, multiplication, power, transpose, left division, right division. Addition and subtractions, since in matrix operation they are the same as the element by element operation. So MATLAB stores the operations as the same thing. Okay, plus minus. So this multiplication without the period punctuation. Okay, power, transpose, left division, right division. So this is matrix-based computation. So all the operators here behave like what we learn in mathematics. It can also apply to scalars. So what are left and right divisions? Okay. So suppose you have a linear system, AX equals to B. You want to find X, right? So in mathematics, you do X equals to A inverse B, right? A inverse B. So that inverse is this. You are dividing from the left, right? Because you have A inverse the left of B. Okay, X equals to A left division B. So you will have the solution for that linear system. But if you have another linear system like this, but another equation like this, it's not a linear system, I think. So you have XA equals to B. If you want to solve for X, you will have B times A inverse. Okay, so inverse, A inverse is kind of similar to, if the scalar we have, let's say, a number inverse is 1 over the number, right? So yeah, this is A inverse, and kind of like we are dividing. B divides A, but A is to the right of B. So we do this. X equals to B slash A. Okay? So for both cases, MATLAB will give you the solution if the system is consistent, meaning that the rules from linear algebra applies. A has to be non-singular, you know, things like that. Okay, we have some examples here. Let's just do that since we have some more time. Clear CLC. So we have the same thing. A equals to 1, 2, 3. So A is a row vector. B is a column vector. 3 by 3. And then we want to do matrix multiplication. Can do that. 3 times A. So this is matrix multiplication. Okay. So this is different with A times B is different with A dot times B. Okay. Next, we've done matrix operations, and we have some nice functions. These are some of them. There are lots of them in the help documents. Because some of the frequently used functions. If you want to create an identity, you can just do I and then put the dimension. Then MATLAB will automatically create the identity. If you want to create matrix full of zeros, you can also do that. Like that. Matrix full of ones, you can do that. If you want to call only the diagonal of the matrix, you have that. If you want the upper triangle, the upper triangular of a matrix, lower triangular. If you want to create, so this is what I used before. If you want to create a random square matrix, random n with one input. If you want to create a random rectangular matrix, but not square, you can have n, different values of n and n. But if you do 2, random 2 by 2, you will get a 2 by 2 random matrix. And then you can also create a Hilbert matrix, n by n Hilbert matrix by this built-in functions.
Random.
Some examples. This is going to be the last slides. Let's do that.
Oh man.
Here's CLC. So for example, we want to create a matrix 0, 2 by 3. Okay. Sometime when you want to solve problems, we have from linear algebra, our matrix is sparse matrix, meaning the matrix is full of zeros. Only at some locations they are non-zeros. So it's easy. You create a matrix full of zeros like this. For example, zeros with 100 times 100, like that. So store it in the matrix, say call A, like that. And then just pick the position with non-zero values, and then you change that value, right? So that's the trick. So if you do zeros with one input, you have a square matrix, 4 by 4 matrix. Okay. What I used before, if you want to do randomize a matrix, a 5 by 6 matrix with random elements. Okay, so you have that, right? Sometimes you just want to test your function. You're writing some coding, and you want to test some function with some matrices, so you can do this. You can put this in your loop, and every time the code runs, it will generate another new matrix, right? So they are both different. Before this, when I learned about MATLAB, when I first learned about MATLAB, when we want to use random, we have to specify the seed. I think yeah, in the you have to input the seed number, meaning that behind there, MATLAB stores some terms called seeds, where seed 1 is one method to randomize the number, seed 2 is another method, seed 3 is another method. So when we want to create random numbers, we have to specify the seeds. So now no more. Okay, so with the matrix, if we want to just access the diagonal, okay, the diagonal of the matrix, you have that, okay, with the diagonal. So whenever you can fetch the, let me try if I can do that. Now that maybe I'm a little, let's say we say that we want to take the diagonal and we want to replace that with 10. Okay, so we can do that. Cannot do that. So diagonal is just fetching the values, not assigning the values. Okay, diagonal, and then for example, okay, if you have a matrix like this, 5 by 6 of the values, and then you want to create another matrix of the same size, but how do I explain this? Okay, so if you have a matrix, some matrix, you want to create another matrix of all zeros, but with the same size. You can do that with a built-in function size. We can check, okay, what is the size of matrix? Okay, it's 5 by 6. So for example, if you just get the matrix, you don't know the size of matrix. So that's the size 5 by 6. So now I want to create a matrix full of zeros of the same size for whatever reason. Okay. So you can just write a line of code like that. Zeros of size of matrix. You can also write A equals to size of matrix X, and then zeros of A, right? That's what we'll love to do. But in coding, writing these two lines will consume more time than just writing this one line, because in these two you are adding variable assigning, so that's going to take some time out of the computational time. Okay, clear CLC. So what about a vector? So say I want to create a vector of 1 by 4. What about the diagonal of a vector? Okay, so we thought that it will take just this one, right? But if the input is a row or a column vector, MATLAB will take the first element and make it the first, let's say the vector is 4 elements. So MATLAB will create 4 by 4 matrix, where the first element would be the first diagonal, the second element would be the second diagonal, and the third element the third, and so forth. Okay, this is useful when from the applications. Okay, sometimes we have a vector, and then we want to do multiplication. Right? We want to multiply this vector. We want to do matrix multiplication, but those are matrix. These are row vectors, so we can transform the vector into a matrix. Okay, next. Here, CLC. One matrix. So I want to create a matrix full of 1, 3, like that. So it's a 3 by 3 matrix full of 1s. Okay, same deal with a 0 matrix. Sometimes you want to create a matrix where most of the entries are 1, only a certain location that is not 1, then this is useful. Okay, so diagonal of that matrix, let be 1, 1, 1, 1. What about diagonal of a diagonal? Okay, diagonal of this diagonal. Diagonal of this. Recall that a diagonal of a vector is a matrix whereby the diagonal entries of that matrix is the 1, 1, 1. Okay, okay, identity matrix. You can also use all the built-in functions to build another matrix. Okay, for example, you have one matrix that's 3 by 3, and you think that okay, but I want from the application I want to add some zeros right here beside it. Okay, maybe with 3 rows and 2 columns. So you can do one matrix, and like you do matrix definition. You want to add beside the one matrix, so you have to use commas, right? So you want to add a matrix full of zeros. Make sure the number of rows is the same. Number of rows 3. Number of columns, it doesn't matter. So let's see, 2. So you can build up your matrix. Okay, so you have okay 0, 0. I want to add some more zeros down here. That. So you for the down there you have to with semicolon. So you have zeros. You wanna add the same, like you wanna add under the one block here. Okay. Zeros 2. You want to add 2 lines of 2 rows with 3 columns. So 0 matrix. Okay. Error because you're only adding this portion. Okay, without this portion. So you have to add both, meaning that you can either add with 5 columns like that. Okay. Or if you want to add another block there, you have to add that block too. For example, you want to add identity, 2 by 2 identity beside the zeros. Okay, so you have the big matrix. So yeah, it is also useful, I think, in the applications. So that brings us to the last slide of this week. Okay, matrix operations. So yes. Sure. So suppose that you have this matrix. There are 2 questions. Number 1, find a short MATLAB expression to build A. Okay, there's a pattern here, 2, 3, 4. So why don't you use some colon operator, some linspace function to build this A. And then after you build, after you define the A, give me the code to calculate the sum of columns 3 and 6 of A. Okay, column number 3 plus column number 6. Okay, that's it. Any question? From the schedule, we're gonna have our assignment posted actually last week, but yeah, I will try to finish making up the question for assignment 1 this week, and I'll update in the WhatsApp group if I have uploaded the assignment questions. Okay, if there's no question, then thank you. I'll see you next Tuesday, inshallah. Bye.
berak.